Morning, everyone. Welcome to Marina's Powerhouse Team Review and Training Center. So today we are going to discuss the direct current circuits part 8. So please show here on the board. Maxwell's mesh method part 2. So I'll be discussing about the super mesh. No? So this is the continuation of the part 1. Okay, so let us start. We have the Maxwell's mesh method. No? So we have for problems numbers 1 to 4. Okay, so we have a given 3-loop circuit here. Okay, so we have for loop 1, I assign the circulating current I1. Loop 2, circulating current I sub 2. Loop 3, circulating current I sub 3. So take a look here. We have here a 5 ampere current source. So let us have first what is the equation for this 5 ampere. Okay, using the mesh analysis. Okay, so we have here, take a look here. So we have 5 ampere that is upward in direction. So our I sub 3 is also upward. So this is upward. This is also upward. So our 5 is equal to I sub 3 that is upward. That is 5 ampere is upward. I sub 3 is also upward. So that is equal to I sub 3. But there is a current I sub 2 here. Because the 5 ampere current source is common to both loop 2 and loop 3. So we have here I sub 3, the same direction as the 5 ampere, and then I sub 2 that is opposite in direction, which is downward. So we have to subtract. So that is minus I sub 2. So that will be our first equation. Okay, so let us simplify this. Okay, I will have first our negative I sub 2, then plus I sub 3, that is equal to 5. And then I will just put here 0 I sub 1. This is for our calculator. Okay, so we have here our equation number 1. Okay, that is our equation number 1. Okay, then let us apply the mesh analysis at loop number 1. So take a look here at loop number 1. This is loop number 1. Okay, loop number 1. So our I sub 1 is the circulating current at loop 1. So it lives on the positive terminal of 24 volts. So therefore, it is positive 24. That is positive 24. Okay, and then just like what I have teach you last time. So we have I sub 1, the circulating current for loop 1. Okay. So this is for loop 1. Okay, so that is 24. Then make, no, we already derived this. So make the circulating current automatically to be negative. So that is our I sub 1. Then multiplied by the loop resistances. 40. Okay? And then consider 40, that is our common resistor. That is common to both loop 1 and loop number 2. So we have to put here plus. Okay? 40 plus 40, and then multiplied by the adjacent current, which is I sub 2. So we have here our I sub 2. So that is equal to 0. Okay? So again, positive 24 because the circulating current, it lives on the positive terminal of the 24 volts. And then right away, make the circulating current negative I sub 1, then multiplied by, so we have the loop resistances. The resistances connected at this loop, so which is 10 plus 40. Then plus 40 multiplied by I sub 2. Okay, so let us have this. So 10 plus 40, so we have here 50. Okay, so we just have to transpose our negative I sub 1 times 50. Okay, so that is negative will become positive. So I will just put here 50. So that is 50 I sub 1. Okay, negative, it will become positive. And then this positive will become negative. So that is 40 I sub 2. Okay? So that is equal to 24. Is equal to 24. I'll just put here plus 0 I sub 3. So that is equal to 24. Okay? So that will be our equation number 2. It's our equation number 2. Okay? So we have here loop number 2 and loop number 3. Always remember that if we have an independent current source, just like our 5 ampere here, if we have an independent current source, you should avoid this current source when doing the Kirchhoff's voltage law. Okay, so what do I mean? For the meantime, we will disregard, no, we will disconnect, or let us disregard the 5 ampere circuit here. Okay, let us forget this first. Okay, for the meantime, let us forget this 5 ampere. And then take a look at this loop. This loop. Okay, this loop. Okay, I will name this loop as, this is point A, point B, point C, point D. Okay. So this is considered to be the super mesh. Okay. This is the super mesh. Please take a look. Here, we have a super mesh. That one. This loop A, B, C, D, A, we are going to apply by Kirchhoff's voltage law at loop A, B, C, D, A. Okay? So in here, we are going to use simultaneously the mesh analysis and the Kirchhoff's voltage law. As we have said before, that the mesh analysis is just the son of Kirchhoff's law. No? Baga, anak niya lang yun. No? So we can also make use of the Kirchhoff's voltage law. So please take a look at this super mesh. This is what we call the super mesh. Okay? Then we are going to apply the Kirchhoff's voltage law. By the way, we have here current I sub 4. Okay, guys? So please take a look here, I sub 4. In terms of circulating current, I1 and I2, what is the value of our I sub 4? So please take note that our I sub 4 is going downward. Downward. And our I sub 1 is also downward. Okay? So therefore, that is equal to I sub 1. Okay? I4 is downward. I sub 1 is also downward. Downward, downward. Okay? So they have the same polarity, which is positive here. Okay? For the mesh analysis. What about our I sub 2? Take note, I sub 4 is downward because I sub 4 is flowing through our common resistor 40 ohms. That is common to both loop 1 and loop 2. Okay, again, I sub 4 is equal to I1 in Maxwell's mesh method. If they have the same direction here in Maxwell's mesh, this is downward, this is also downward, that is positive. And then there is a current I sub 2 involved here because this is a common resistor. Remember, the 20 ohm here is not a common resistor. Not unless if you have a circuit here, up here. Okay? So this is not a common resistor. Okay, let's go back. So 40, okay? The current flowing at 40 is I sub 4. So we have here I sub 1. That should be minus I sub 2. That is the equation of I sub 4. Okay. I think we are ready to use the Kirchhoff's voltage law. Let us use the Kirchhoff's voltage law here. Okay. So, we have, okay, please focus our camera here. Okay, so, we have the Kirchhoff's voltage law. Okay, let's have first here. We have here the negative 20. Take note, this is our circulating current. This is our circulating current for the KBL. Okay? So again, this is our super mesh. The loop ABCDA is what we call our super mesh. Super mesh. Okay? Now, we have here, take a look here for the 20 ohm resistor. So, current I sub 2 is to the right. So, this is to the right. Please take note, this is to the right. This is also to the right. Okay? So, the circuit tracing is going to the right. This is also to the right. To the right. Again, that is to the right. Okay? I sub 2 is to the right. Circuit tracing is to the right. So, therefore, this is to the right. Meaning, one direction, one line. Okay? So, we have here 20. This is 20 I sub 2. Okay? Again, for 30 ohm. But, please take note that our 30 ohm is connected in series with our 20 ohm resistor. Okay? They are connected in series. So, this is 30 plus 20. So, 30 plus 20. So, this is 50. Okay? So, I sub 3 is going to the right. And also, our circuit tracing is going to the right. To the right. Okay? To the right. So, ganun din, di ba? Pakanan. Okay? Isang direksyon, isang guhit. Okay? One direction, one line. So, we have here 30 minus 30. Then, we have I sub 3. Minus 30, I sub 3. Okay? But, again, I already said that the 30 is in series with the 20. So, 30 plus 20, so we have 50. Anyway, I can make this already as 50. Because of the 50 ohm equivalent here. Okay? Then, what about for the 40 ohm resistor here? For the 40 ohm resistor. Please take note that our circuit tracing here is going upward. Take note, the direction is always clockwise. I always assume the circuit tracing to be in clockwise direction. I never assume it as a counterclockwise. From my college days up to now, I always assume because this is the simplest. Okay? This is the simplest. Okay. So, this is our circuit tracing. The circuit tracing is going upward. So, pataas siya. Pataas. This is upward and I sub 4 is going downward. So, this is upward, downward. Two direction, two lines. Okay? So, we have here 40. 40, that is the resistor. And then, multiplied by the current I sub 4, which is equal to I1 minus I2. So, we have here I1 minus I sub 2, that's equal to 0. Okay? So, let us simplify this algebraically. So, we have here negative 20 I sub 2 minus 50 I sub 3. So, we have here 40 plus 40 I sub 1. And this is minus 40. Then, this is minus 40 I sub 2. That's equal to 0. Okay, again, so we have here our 40 I sub 1 here. 40 I sub 1. What about for I2? We have here I2, right? So this is negative 20. This is negative 40. That will be negative 60 I sub 2. Then we have here negative 50 I sub 3. That is equal to 0. Okay? And that will be our equation number 3. Okay? Okay, so this is our 40 I sub 1. Then we have here negative 20, negative 40, that's negative 60 I sub 2. Okay? Then we have here negative 50 I sub 2. Okay, now, we are ready for our calculator. So, let us have now mode. M is mode 5, 2 in our calculator. So, okay, so what will be our value for our I1, I2, and I3? Actually, in the licensure examination here in the Philippines, no, so this is allowed by the government. This one, the Professional Regulation Commission. This is the Casio FX570 ES Plus. So, this is the best calculator, no? If you are to take the licensure exam for electrical engineering or even in master electrician, this is the best so far. This is approved by our government, this calculator. To our non-Filipino audience, if there are in the near future will be watching to our lecture video, because there is no editing here. So we are using the Casio 570 ES Plus. Okay, that is Casio FX 570 ES Plus. Okay, this black one. You may also use the Casio 991 ES Plus. They have the same function, but unfortunately, just last year, this was disapproved by the PRC. Okay, this is 991 ES Plus actually. But if you see the manual of the 570 and 991, they have the same manual. They have almost the same manual. The function, the keys that you're going to press are just the same. Okay? I just saw a little difference, which is the solar power here. Okay? And this is the second edition. There is a first edition of the 570. But right now, this is the 570. The first edition is out in the market. So this is available in the market now. Actually, we are selling also this calculator. Just in case if you want to order, okay, you may do so. Okay, so let us have the mode 5.2. Let us press our calculator, mode 5.2. For our equation number 1, take a look here, guys. Take a look here. So, we have here 0 equals, then negative 1 equals, then we have here 1 equals, then we have 5 equals, then for equation number 2, we have 50 equals, so we have here negative 40 equals, then we have 0 equals, then we have 24 equals. For equation number 3 here, so we have here 40 equals, then negative 60 equals, then we have negative 50 equals, so we have here 0. 0 equals equals. Okay, our x here, if we are to run off into 2 decimal places, our x is simply our I sub 1. Our I sub 1 is negative 1.89. Is that correct? Did you get that value also? Anyway, we have the PowerPoint to verify, no? Okay, we are quite lucky because in the licensure exam, the questions are all in multiple choice, no? If your answer is on the choices, well, you have a bigger probability that you are correct. You are already correct that if your final answer is on the choices. That's already a lead. Okay, negative 1.89. And then another equals, which is our y, which is our I sub 2. I sub 2. So this is negative. Again, this is negative 2.96 amperes. Then for our z, another equals, there you have a positive value. So you have 2.04 ampere. Anyway, this is our I sub 3. Okay, let us get our I sub 4, by the way. So, what is our I sub 4? Our I sub 4 here is I sub 1 minus I sub 2. So, we have I sub 1 minus I sub 2. Then, what is our I sub 1? Negative 1.89 minus I sub 2, which is a negative 2.96. So, that is equal to, negative negative will become positive. So, this is 2.96. That will become minus 1.89. So our I sub 4 will be 1.07 amperes. Okay, so this is our I sub 4. Okay. Okay, so we have our I sub 1, we have I sub 2, we have I sub 3, then we have our I sub 4. Okay, so let us have first our I sub 1 here. Our I sub 1 is negative 1.89. So, what letter is 1.89 here? Negative. Okay, the answer will be letter B. Okay, so therefore, that's checked. No, we are correct. Okay. For number 2, our answer on the board is negative 2.96. So, here, the answer will be letter D. Okay. Then for number 3, our answer is 2.04, just like what's on the board. Okay? For I sub 4, we have 1.07. Yes, that's correct. Okay? Therefore, we are correct. Okay? Are there any question first to our audience? No? So, pakita nga natin sila. Baka may tanong dito sa first. I'll be solving around 14 items. Okay? Any question, Leo? Question, Rodney? Sir Joey? Are there any question? Pag wala, tuloy ko lang. Nagets ba? Thumbs up lang kung nagets. Okay. Sige, so let's go to the next problem. For problem number 5 to 9, find the branch current. Anyway, I have to draw the circuit for numbers 5 to 9. Okay? So, let us discuss problem from number 5 to number 9. So, we are asked to find the currents I1, I2, I3, this is I4, and this is I5. No? So, please take note that the I1 flowing at our 10 ohm resistor, that is also this circulating current because they are just equal. Okay? This is not a common resistor. Okay, so this circulating current I1 is also this I1, the current flowing in the 10 ohm resistor. We have here our I sub 2, the circulating current I sub 2 is also this current flowing to our 5 ohm resistor. Take note, this is not a common resistor. The 2 here is a common resistor. Common to both loop 1 and loop number 2. Okay, the I3 here is this circulating current I sub 3. Ito rin mismo yon. Okay, ito rin mismo yon. So, this is for the current flowing to our 4 ohm resistor. Okay, what do we have here? No? So, first we have our I sub 4. Okay, what is the equation for our I sub 4 here? I'll just put it in here. So, what is our I sub 4 equal to, guys? So, our I sub 4 is going downward. Then, I sub 1 is also going downward. So, therefore, it is I1. Downward, downward. Okay? This is using the mesh analysis. Huh? Okay? If this is downward, this is downward. This is I4 is equal to I1. Positive I1. But, this I4 is flowing through the 2 ohm resistor, which is the common resistor. So, the current I sub 2 is going upward. That is reverse with respect to the direction of I sub 4. Okay? So this is downward. I sub 4 is downward. But our I sub 2 is upward. So this is minus I sub 2. What about for I sub 5 here? Take a look. Our I sub 5 is going downward. If this is downward, our I sub 2 is also downward. Downward, downward. So that's equal to positive I sub 2. Then minus, because I sub 3 is going upward, minus I sub 3. Okay? Did you get that? So please take note that we have an independent current source. So meron tayong independent current source dito na 2 amperes. So it is very obvious by visual inspection that our I sub 1, okay, I sub 1 is simply equal to 2 amperes. 2 amperes. I sub 1 simply equal to 2 amperes. Okay? It's equal to 2 amperes. 2 ampere is going up, and our I sub 1 is also, if you are to trace, that's also going up. So they have the same direction. So therefore, that's positive. The 2 is simply equal to I sub 1. Okay? And then, so let us have for this loop, for loop number 2. So, at loop 2 here, okay, so please take a look at loop number 2. There's no voltage source. So let us apply the mesh analysis. Okay, right away, make the circulating current as negative. So that will be negative. Okay? Negative I sub 2 multiplied by the loop resistances, which is 5 plus 2 plus 2. So we have 5 plus 2 plus 2. And then plus, what about here? Plus 2, okay? This is plus 2. Remember, we are applying the mesh analysis here. Let's take note. Please do not mix up the mesh analysis and the KBL. Please do not mix up. Okay? So, again, this is by the mesh analysis. Or just simply make it, yeah, I call this as the triple M because Maxwell's mesh method, the triple M. By triple M at loop number 2. Again, so we have negative circulating current at loop 2 is I sub 2 multiplied by the loop resistances, 5 plus 2 plus 2, okay? 10 plus 2 multiplied by the adjacent current. So, sino yung adjacent? Yung katabi niyang kuryente dun sa loop 2. Ito yung resistor na kino-consider. I sub 3 yon. So, plus 2, I sub 3. Okay. What about here? O, dito naman. O, di plus 2, ano yung adjacent resistor natin? So, 1. So, that will be equal to 0. So, please take a look here. Let us simplify. So, we have here 2 I sub 1. 2 I sub 1. So, this is 2 I sub 1. Okay. And then, this is 5 plus 2 plus 2, which is 9. So, minus 9 I sub 2. Okay. Negative 9 I sub 2. So, we have here plus 2 I sub 3. Plus 2 I sub 3. Okay. So, that will be equal to 0. That will be equal to 0. Okay. So, we have this equation now. We have this equation now. Okay. For loop number 3. At loop 3. So, please take a look here at loop number 3. We have a voltage source of 100 volts. The circulating current I sub 3 lives on the negative terminal of 100 volts. So, therefore, it is negative 100. Negative 100. Then, automatic, our circulating current I sub 3 is negative multiplied by the loop resistances. Okay. So, this is 4 plus 2. Okay. And then, this is 4 and 2, the loop resistances multiplied. This is plus the common resistor, which is 2, multiplied by the adjacent current, which is our I sub 2. So, that is equal to 0. Okay, so we have here 2, this is 2I2, 2I2, and then we have minus, this is positive 2I2, then minus 4 plus 2, so we have 6. 4 plus 2, we have 6 I sub 3. Okay? Then, we have negative 100. I will just transpose the negative 100. So, this will become positive 100. Then, I will just put here 0 I sub 1. Here. Okay? So, by the way, let's take a look here. Again, I will make this as equation number 1. This is equation number 2. By the way, we have our I sub 1. By inspection, again, I sub 1 is simply equal to 2. We should have 3 equations, okay, to solve the 3 unknowns. So, we have, how I will going to make this as an equation. I1 is equal to 2. Okay. This is how you will make this. We have I sub 1, then we have plus 0, I sub 2, make this as 0, then plus 0, I sub 3, that is equal to 2. There you are. You will now have our equation number 3. Let's make this as equation number 3. Okay? Then we are now ready to have the mode 5-2 in our calculator. Sige mga kawerpa, pindot sa calcu. So we have mode 5-2. Again, equation number 1. 2 equals, we have negative 9 equals, 2 equals, so we have here 0 equals, equation number 2. We have 0 equals, we have 2 equals, we have negative 6 equals, we have 100 equals, so we have here 1 equals, so we have here 0 equals, then another 0 equals, then lastly we have 2 equals, then press now equals. So our x is simply equal to 2. Our x simply equal to I sub 1. Okay? So therefore, our I sub 1 is equal to 2. Another equals. So our y that is equal to I sub 2. Okay, so that will be negative 3.52 ampere. Okay? Negative 3.52 amperes. Then for our I sub 3, that will become negative 17.84 amperes. Then for our I sub 4, guys, I sub 4, okay, I'll just follow this one. I will input already the given. So our I sub 1 is 2. Okay, mode 1 in your calculator. So that will be 2. Then it says here minus. Okay, minus, this is minus. So that will become plus. Okay? Minus, minus, that will become plus. So we have 3.52 equals. So we have here 5.52 amperes positive. Then for our I sub 5. Our I sub 5 is I sub 2 minus I sub 3. So we have here our I sub 2. I sub 2 is negative 3.52. Negative 3.52. Then this is minus. Minus I sub 3. Minus, minus, it will become plus, right? Minus, minus, so that will become plus. So we have 17.84 equals. So that will be 14.32 amperes. Okay. So that will be our answer. This is actually for number 5, number 6, number 7, number 8, and number 9 questions. Let's have first. Okay, in our PowerPoint. Okay. In our PowerPoint, okay, I will just read what is on the board. Our I1 is 2 ampere. Anyway, that's obvious. That's already given, right? Okay, for our I2 in the board is negative 3.52. Okay, that's correct. That's letter D. For our I sub 3, that is negative 17.84. There you are. That's letter A. Okay. For number 8, that is 5.52. Yes, that's correct. Letter A also. Then for number 9, that is 14.32. Okay, that's letter D. Okay? Can you follow? Did you get that one? Okay. May I see our audience? Are there any question? Please raise your hand now. No? You are allowed to speak or to ask question. That is your advantage. Please ask now. Okay, are there any question, guys? So please, sino may tanong sa inyo? Leo, may tanong ba? Rodney, who has question? Raise your hand. No question? So if you are not raising your hand, I will continue. Okay, I'll just continue. You're not raising their hand. Okay. So I will now solve the next problem. For number 10, find the circuit as shown. Okay, I'll show you this circuit. For number 10. Okay? By the way, let's go back to number 6 here. Okay. So our answer is negative 3.52. So meaning the assumed direction is wrong here. That is supposed to be going to the left. Okay. So there will be no problem, no, because we just assume that this is going to the right. If your final answer is negative, meaning the actual flow of current here, it will be going to the left. No? Meaning you, of course, initially you are just assuming some direction for the currents. Okay. So also, if you have a voltmeter, so if you got a negative value in the voltage, so it is automatically to be wrong assumption. So there'll be no problem. So wala namang problema doon. Ibig sabihin, mali lang yung na-assume mo na direction. No? Kung sa voltmeter naman, yung polarity. No? So, walang problema dyan. Okay? So, let us have now number 10 question here. So please take a look here. So find V in the circuit shown. So we have our V here. In our circuit, our V. Okay, find V in the circuit shown. Please take note. Please memorize the choices. It's easy. Letter A is 5. We have 5. We have 7. We have 4. We have 9. Again, 5, 7, 4, 9. Okay. So let's go over with our circuit here. Okay. So this is the circuit. So we have here a 2 ohm resistor, 8 ohm, and 2 ohm resistor here. Okay. Then we have here, we are asked to find the voltage drop. The V is actually the voltage drop across the 8 ohm resistance. So please take note that this is actually a voltmeter. A voltmeter. This is the positive of the voltmeter. This is the negative of the voltmeter. Okay? So, the assumed direction automatically, okay, it will be, the current will be pointing in on the positive terminal of the voltmeter. So, it will be pointing in like this. Well, of course, this will be considered as your current. I will assume that this is current I. Or I will make this, guys, as I sub 2. I sub 2. Okay? Because I will make this a circulating current. This is circulating current, I sub 1. This is circulating current, I sub 2. Okay? This I sub 2 is also this I sub 2. And this circulating current, we have here I sub 3. In here, you will see that there are two independent current sources. See? We have the 6 ampere. What is the 6 ampere? Is that is equal to what? By equation, this 6 ampere is going up. The 6 ampere is going up. And then I sub 2 is also going up. 6 ampere going up. Then I sub 2 is also going up. So therefore, that is equal to I sub 2. And then 6 ampere going up. Then I sub 1 is going down. So therefore, that should be minus I sub 1. That will be the equation. That is our equation. Okay? So, well, let us have our equation number 1. So, how to do it? So, we have here negative I sub 1, okay, then plus I sub 2, then plus, I will make this as 0 because there's no I sub 3 here. 0 I sub 3, that is equal to 6. So, I will make this as equation number 1. Okay? What about for the current source? 3 amperes. 3 amperes current source. So, what is that 3 equal to? Remember that 3 is going upward. 3 is upward. I sub 3 is also upward. So, upward, upward, therefore positive I sub 3. Remember, we are applying the mesh analysis. Okay? So, this is our I sub 3. upward, upward. Then that is minus I sub 2. Why? Because I sub 2 is going downward. Okay? They have different direction. This is upward and this is downward. So therefore, it is negative. Well, that is opposite with respect to the Kirchhoff's law, right? In Kirchhoff's law, if you have one direction, that is negative. If you have two direction, that is positive. That is the little difference, no, between the mesh and the KBL. Okay. Well, of course, it's you're applying this differently because they have these are two different methods here. So we have I sub 3. Take a look. I sub 3 is going upward. So the 3 is upward, positive I sub 3. Then we have here minus I sub 2. Okay, let us simplify this. There's no I sub 1 here, so I will just put 0 I sub 1. Then this is minus I sub 2. Then plus I sub 3. Okay, plus I sub 3. That is equal to 3. Okay, so that will be our equation number 1. This will be our equation number 2. What about our equation number 3? There we need a super mesh. Always remember that we have to disregard the current sources. I-disregard natin yun. Hindi natin i-consider yan sa loop. Well, this is by mesh analysis. Okay? By mesh analysis. Now, always remember, if we are considering the super mesh, we have to apply now the KBL. Okay? By the Kirchhoff's voltage law. So meaning we are using the mesh analysis. And the KBL simultaneously. Can it be done, sir? Yes. That is the advantage. As I've told you before, mesh analysis is the son of Kirchhoff's law. Okay? So anak niya yun eh. Anak niya to eh. So pwede mong gamitin. But when are you going to use the Kirchhoff's voltage law? That is for the super mesh. Again, this is what we call the super mesh. Where is that super mesh? Okay. Where is the super mesh? Okay. So, I will have a circuit tracing for the super mesh. This is the circuit tracing for the super mesh. Okay. So, do not consider 6 and 3 ampere. Hindi kasama tong dalawang current sources na to. Okay? What you will consider only is the loop A, B, C, D, and A. Apply KBL, okay, at loop A, B, C, D, A. Okay? So, ganun lang, mga ka-ware pa. Okay, so what do we have now? What do we have here? Let us have first our voltage drop here in the 8 ohm resistor. Remember that our circuit tracing is going to the right. I sub 2 is going to the right. Okay? Then I sub, the circuit tracing is going to the right. So to the right, to the right, to the right also. Right? Pakanan, pakanan, pakanan. Okay? You see? To our non-Filipino viewers, if there are, or maybe in the near future, you will watch my video, don't worry, no? Although from time to time, I'm speaking our language in Filipino, but what I'm doing is not, I'm not mixing up. We call that in the Philippines as Taglish. But this is not a Taglish. I'm explaining first in English, and then after that in Filipino. So, therefore, there will be no mixing up. There's no problem here. Okay? So, just stay there. Okay? Just listen carefully. I'm very sure that you will understand this. Okay? So, maybe in the near future, there will be some African students, no, will be watching our video. That's our dream, no? To help the electrical students around the globe. Okay, again, let us apply the KVL in the SuperMesh. This is the SuperMesh. Okay? Again, I sub 2 is going to the right. The circuit tracing is also going to the right. To the right, to the right, to the right. So, we have here our I sub 2. So, okay, I will have first 8. So, that is 8 I sub 2. Okay? So, 8 I sub 2. That should be negative kasi the same direction. They are the same direction. The right to the right. What about in the 2 ohm resistor here? The current flowing in the 2 ohm resistor is I sub 3. And remember that our I sub 3 is going downward. And our circuit tracing, the color black marker here, this is downward. Okay, this is downward. Then our I sub 3 is also downward. Okay, downward, downward, one direction, one line. Okay, so we have here 2 I sub 3. Okay, then what about now for the 2 ohm resistor on the left side here? The current I sub 1, which is the circulating current, that is the current flowing through our 2 ohm resistor. If we are to trace that, that is on an upward direction. Upward. Okay, that is upward, and our circuit tracing is also upward. Upward, upward, one direction, one line. So that will be 2 I sub 1. 2 I sub 1. That will be equal to 0. 1, 2, 3 terms. 1, 2, 3 terms, or 3 elements. Okay? Let us simplify this algebraically. Okay, I don't want to see any negative here. Okay? Let us convert all the negativity into positivity. Okay? I don't want to see any negative here. Let us transpose this one on the right side. So therefore, all the negative will become positive. Okay? So that will become 2I1. Okay? And then plus 8I2. Okay? And then plus 2I3. Ayan. Ayoko nang makakita ng mga negative na yan. So, dito tayo. Puro positive. Ba? Ayan. 2I1 plus 8I sub 2 plus 2I sub 3. O, equation number 3. So, this is now easy. Y mode 5, 2. Okay. Again, take a look at our equation. We can now solve this easily by our calculator. We will not go with Kramer's rule, determinants, elimination, substitution. Will not go there. We'll just use directly our calculator. Press now mode 5, 2 again. Okay, for equation number 1, we have negative 1 equals, so we have here 1 equals, we have here 0 equals, we have here 6 equals. Equation number 2, we have here 0 equals, we have here negative 1 equals, then positive 1 equals. Okay, so we have now 3. Okay, that will be 3 equals. Okay, 3 equals. Then we have equation number 3. 2 equals. 8 equals. 2 equals. 0 equals. Then press now equals. Okay, the answer is 11/2, or which is negative 5.5. That is our answer. For our I1. Our I1 is negative 5.5 amperes. What is our I sub 2? Another equals. Okay, so this is just 1/2 or 0.5 ampere. Then our I sub 3, guys, that is 7/2 or 3.5. 3.5 amperes. Okay, so that will be our answer. By the way, the only question is V. What is our V? So our V will be equal to I sub 2 multiplied by 8 ohm resistor. So our V now is I sub 2.5 times 8. So our V will be 4 volts. That's the answer. So the answer would be letter, anong letter sagot natin mga kawerpa? Letter C. Okay? Very easy. Okay. Dali lang, di ba? Oh, any question? Are there any question before I will solve the last problem? The last problem sets. Okay. So any question? Are there any question, everyone? Everybody? You may ask now. If there are none, I will continue. Okay, I will just continue this. Napabilis yata ako. Tama ba to? 10:35 lang. last problem na to eh. Oh, any question? Mukhang napabilis ako ah. Any question? Leo, baka may tanong. Okay. Wala ba? Wala. Ganun lang. Pag wala, parang Miss Universe lang. Ganun. Wala? Si Rodney. Kilala mo ba yung basketball player ng Alaska, si Rodney Santos? Doon kaya kinuha pangalan mo? Naabutan nyo ng tatay mo? Kilala mo yon si Rod? Do you know him? Rodney. Sumikat yun nung araw, si Rodney Santos.
Opo.
He is the slasher, no? Sikat yun nung araw, no? Player ng Alaska. Kasama yun sa alam ko eh. Kasama yun sa Grand Slam. Kampi nila Jojo Lastimosa. Okay. Rodney Santos. Sir, because I love basketball. As we all know, basketball is the #1 sport in our country. Okay. That's why every basketball lover are very sad when Kobe Bryant died last January. Okay. Even my nephew is crying, no? Why Kobe Bryant dies. Okay. Yes, Sir Garcia. You are there. Thank you, sir. No, you are very industrious. No? Napakasipag ni sir. Nasa trabaho ka ba ngayon, sir? Alam ko, nasa trabaho ka eh. Tama ba?
Opo, sir. Opo. Katatapos lang actually ng meeting, kaya na-late ako.
Is your boss is there?
Wala, sir. Nasa kabila. Nasa P1.
So, you're lucky that your boss is not there. Okay? You are typing and you are studying. I will sumbong you to your boss. No, of course not. Okay, that is, I still do believe that your company will be benefited if you become a licensed engineer. Your boss must be supportive enough because he'll be the one will be benefited also. Okay, not only you. Only you. Okay. So, are there any question? No question. I will solve the last and the hardest problem. Because this will take around 2 hours to solve. So, this is the hardest problem. I will draw our circuit. First, ako ba itong maisulat? Ito na lang. This is from problems 10 to 14.
Paano mo
10 to 14 problem. Paki-mute natin sila. Okay, let us solve now this problem. This will be our last problem sets. Okay, so please listen carefully. Okay, we will be solving our currents. So there will be 5 unknowns for our circuit. So we have I1, I2, I3. Where is that? This is our I1. This is our I1. This is our I2. The mesh current. This is equal to I3. Okay? So I1, I2, and I3. Okay? Of course, our I1 here, that is the current flowing here, going to the 200 volt source. This is our I1. What about our I2? Okay? On a clockwise direction, so this is our I sub 2. Okay? Then, this is our I sub 3. This is I sub 3. The circulating current is also this. Ito rin yun. Okay? This is our I sub 3. By the way, what is our I sub 4? Okay? So, this is our I sub 4. This is our I sub 5. So, please, take a look here on the board. Paki-close up pa natin. Okay? Please close up. Okay? So, we have a 3-loop circuit here. Okay? So, please listen carefully. This is the most complicated problem that we're going to solve today. So, we have here our 5 ampere. We have our 5 ampere current source. 5 ampere. The 5 ampere is going up. That is going up. The 5 ampere going up. 5 ampere going up. Our I sub 2 is also going up. So therefore, our 5, okay, we are applying the mesh analysis. Huh? So the 5 will be equal to what? Going up. The I sub 2 here is also going up. So therefore, it's equal to I sub 2. What about our I sub 1 that is going down? Okay? So 5 ampere is equal to I sub 2 minus I sub 1. Okay? So, let us have the equation. Let us set up the equation now. So, we have here negative I sub 1. So, I've just put here negative I sub 1. And then plus I sub 2. And then we have here plus 0. I'll make this a 0. I sub 3. So, that is equal to 5. There you are. So, this will be our equation number 1. Okay, guys? That is our equation number 1. Let us have now this loop. Remember, I cannot apply the mesh analysis here on loop 2 because there is a current source. Cannot apply here. I will apply the mesh analysis to loop number 3 here. Of course, this is by mesh analysis. And then let us apply at loop 3. I will have it on loop 3. There is no voltage source here. So I will just make what we have learned before last time is for a certain loop, there is no voltage source here. So make the circulating current as negative, automatically negative. Why, sir? I already discussed this in the first module, in the first part of mesh analysis. So please, if you did not watch that video, of course, this is an advanced topic of mesh analysis. So I advise you to watch my Mesh Analysis Part 1. This is too long because we already derived this. It's very long if we'll do it here. Okay. So, please take a look here at loop number 3. Again, make the circulating current as negative I sub 3 for loop number 3. And then, multiplied by the loop resistances. What are these? 10 plus 20 plus 30. 10 plus 20 plus 30. Okay. And then plus what? Plus the product of the common resistor. This is common resistor, the 20. Multiplied by the adjacent, okay, circulating current, which is what? Because this concerns the I5 here. The I5 concerns with the current of I3 and I2. So, plus 20 I sub 2, the adjacent current, I sub 2. Okay, what about for the 30? Plus 30, this is I sub 1. Is equal to 0. Okay, let us simplify this. We have positive 30. We have 30 I sub 1. For I2, plus 20 I sub 2. What about I3? Negative. So this is 60. Okay? 30 plus 20, 50 plus 10, negative 60 I sub 3. That's equal to 0. See, again, I'm not great or very good in mathematics. Maybe I will make a vlog. You don't have to be a great in mathematics if you want to become an engineer. Di mo kailangan magaling sa math. Ako po, hindi ako nag-board exam ako pinakamababa ako sa math. Sa lahat ng score ko, math, ESAS, EE. Pinaka-lowest ko, math. Nag-board exam ako. Nakita nyo nga, oh. Niisip ko pa, oh. 10 plus 20 plus 30, no? For elementary student, this is very easy, right? 60. Me, I will think it because I want to make sure. Because even if this is negative, you make this as positive, everything will be wrong. That is the hardest thing in mathematics. Mali ka lang ng isang guhit, mali na lahat. Isa lang ang mali mo, mali na ka na lahat. If you make the negative into positive, okay, everything, okay, will be devastated. Okay? Everything will be wrong. Okay? So, we really have, I remember when I took my licensure exam, no? 2 plus 7. To make sure I'm very, that is the problem, no? For a student or examinees in the board examination here in the Philippines. Even my professor is saying that, Engineer Francis Caragatan, even though he take the top 3 in the licensure exam, because he also said this when I was his student before in the university. Sa board exam, alam nyo, minsan 2 plus 3, kakalculator nyo pa para kayo makasigurado. Pagtatawa na nga tayo ng mga high school graduate at elementary. No? Baka sabihin, engineer ka pa naman, tagal mo mag-ano. Totoo yun. No? You are not, if you want to become an engineer, doesn't have to be great in mathematics, no. No. You just need an average student in mathematics. That is the misconception to many students. No? That is a misconception. So, please, do not put in mind, if you want to become an engineer, you have to be great in mathematics. You have to be excellent in mathematics. No, I disagree. I disagree. Because I am not great in mathematics, but I become an engineer. I'm not. No? What's important is you have the enthusiasm. Is you have an interest on what you are doing. You love what you are doing. That's the most important thing. Okay? Naintindihan ba ako, mga kawerpa? Thumbs up nga kung agree kayo sa sinasabi ko. Ha? Hinan ko nga, di yata nakikinig tong mga to eh. Di yata nakikinig si Sir Sir Garcia, oh. Okay, sige. Let us continue this. Okay, again. Ba't ba tayo napunta doon, partner? Okay. So, for loop number 3, again, we have to make the circulating current automatically to be negative. I sabi. Napansin ko kasi yung oras parang ang bilis ko kaya medyo nag-relax ako ngayon baka hindi nila maintindihan agad So, hinay-hinay lang, ika nga, no? Mabilis ka nga nagturo, di mo naman naintindihan ng estudyante, wala ring kwenta yon. Walang kwenta, maraming profesor, ganun So, makinig ha. Makinig, please listen carefully. Negative I sub 3 for this loop. Automatic, make this as negative. Okay, we derived this already before. Multiplied by the loop resistances, 10 plus 20 plus 30. Then plus 20 I sub 2 plus 30 I sub 3. Okay? 30 I sub 1, I mean. So, positive 30 I sub 1, okay, plus 20 I sub 2, okay, minus 60. Okay, the 30 I sub 1 is this, the 20 I sub 2 is this one, the negative 60 I sub 3 is this one. See, I'm not great in mathematics. I'm just an enthusiast. Ibig sabihin, interesado lang ako dito. Yun ang mahalaga. Hindi mo kailangan super talino sa math. Hindi. Magiging engineer kayo kahit di kayo kagalingan sa math. Tandaan ninyo yan. Lalo na ngayon, may calculator na, oy. Okay? Okay? So, let's continue. So, I already have two equations. 1, 2. But if you want to take up a course on BS Mathematics, I think there you have to be very good in mathematics. If your course is BS Math or BS Statistics, it's very important. But I remember when we were in college, no, in the quiz show, kalaban namin sila. They are our opponent in the quiz show. But still, engineering won. But there are years engineering won in the quiz show. But there are years, Lota. Lota, talo. No? Magagaling yung mga BS Math sa math BS Math student, they are great in math. Many of them, because they extract square root manually. See? We engineering, let's do the calculator. Okay? Because I have a classmate, I remember, he is a BS Math. Biro mo yung square root, minamano-mano lang. Paano yan? Nagpaturo nga ako Hindi ko pa rin naintindihan Okay. So, ganito Ang ibig ko sabihin, mga kawerpa, hindi mo kailangan super talino sa math. Kailangan lang math lover ka. Yun. Diba? Iba naman yung math lover sa great in math. Iba yun. Many people said that the meaning of math. What is the meaning of math? I saw a t-shirt. Math. You see, math. Math. This is mental abuse to humanity. See? Mental abuse to humanity. They give a meaning for mathematics. I disagree with that t-shirt. No? Because every day we encounter mathematics. Today is the salary of our staff. Okay? I have to use mathematics. May calculator. Okay? So, again, di na tayo natapos dito. Okay please listen carefully. Nakikita ko kasi parang ang bilis ng discussion ko dun kanina. Eto Eto na tayo. May lakad pa pala kami. Eto please listen carefully. Okay. So, I consider loop number 3. Now, where is the other equation? Ano kaya ang isang equation na gagamitin natin? No? Ano kaya ang isa pang equation na pwedeng gamitin? Mga kawerpa. Anong equation Tingnan natin ang sirkito natin. We have our circuit. Okay? I will consider a SuperMesh. I will disregard this. If we mean SuperMesh, you have always to disregard the current source. Okay? That one. We disregard the current source. Please listen carefully, children. Okay? Please listen, children. That one. Okay. You see, the color black. Nakikita ba yung color black? Paki-close up mabuti. Yan. The color black, this is our circuit tracing. Please take note of this. Okay? I will have a Kirchhoff's voltage law at this loop. This is the SuperMesh by Kirchhoff's voltage law at SuperMesh. Let's have that. This is the SuperMesh. If I mean the SuperMesh, that is loop A, ABC, of course, A, B, C, D, E, F, A. Okay? So, there's no G here. Okay? We are considering this loop. This loop. Okay, now, let us apply the KBL. Okay. Kirchhoff's voltage law. Take a look here. We see here at 200 volts. The circuit tracing is going upward. Then it leaves on the positive terminal of 200. Therefore, it is positive 200 volts. For the voltage source, 100, it leaves on the negative 100. So therefore, negative of 100, negative 100. Now, what about the voltage drop here in the 30 ohm resistor and on the 20 ohm resistor? What about first on the 30 ohm resistor? So this is what, guys? This is going to the right, and also the tracing is going to the right. Therefore, going to the right also. So we have here 30 I sub 4. Okay, guys. Then what about here? I sub 5 going to the right. So this is minus 20 I sub 5. Okay, that is equal to 0. So please take note here. Oh, by the way, sir, there is I4 and I5. No problem. Okay? Let's have the equation for I4 and I5. What is the equation for I4? Let's take a look here again. Okay? Take a look. What is the equation for I4 here? This is our I4. That is going to the right. Then I sub 1 here is going to the right. Okay? Okay? So, therefore, that is I sub 1. I4 is equal to I sub 1. And then our I sub 3 is going to the left. So therefore, that is I1 minus I sub 3. What about our I5, guys? Take a look here at our I5. Okay? This is assuming you consider our I sub 2 here. This is going to the right. Okay? This is also going to the right. To the right. So this is I2 is to the right also. So therefore, that is equal to I2. Then what about our I3? That's going to the left if you are to trace. Going to the left. So therefore, that is minus I sub 3. That will be equal to 0. Okay? Now, what we will do here is to substitute 200 minus 100. So we have here 100. So this is negative 30. Okay? Negative 30 multiplied by I sub 4. So our I sub 4 is I1 minus I3. I1 minus I sub 3. Okay? negative 30, I1 minus I3, minus 20. What is our I5 equal to? Our I5 here. Okay, nakikita ba nila to? So, our I5 is I2 minus I3. So, that will be equal to 0. So, we have I2 minus I3. Okay, let us simplify algebraically. So, we have 100. Let's take a look, guys. So, let us distribute this. Negative 30 multiplied by I1. So, that is negative 30 I sub 1. Negative, negative, positive. This is positive, negative, negative, positive 30. I sub 3. Okay, then we have here minus 20. Minus 20. We have here I sub 2. Minus 20 I sub 2. Okay, negative, negative, positive. Plus 20 I sub 3. That will be equal to 0. Okay, let us simplify further. So we have here 100. We have here, okay, so we have negative 30 I sub 1. What about for I sub 2? Negative 20 I sub 2. What about for I sub 3? These two are I sub 3. So this is 30 plus 20. 30 plus 20. Calculator. Okay, 50. So, so we have plus 50 plus 50 I sub 3. Okay, that will be equal to 0. Now, I don't want to see any negative here. Let us transpose the negative, negative on the right side of the equation. We'll be having positive 30 I sub 1. Negative will become positive. Negative will become positive 20 I sub 2. But, of course, no choice. We have 50 positive will become negative. Then, that is equal to 100. Therefore, we'll be having our equation number 3 now. So, this will now be very easy. Okay? Okay, now, press now mode 5-2 in your calculator. Come on, guys. Mode 5-2. Okay, for equation number 1, so we have negative 1 equals, so we have here 1 equals, we have 0 equals, we have 5 equals. For equation number 2, we have here 30 equals, 20 equals, negative 60 equals, 0 equals. Equation number 3, so we have here 30 equals, 20 equals, negative 50 equals, then 100 equals. Okay, now I have a value here for our I sub 1 that is 10 ampere. For our I sub 2, which correspond to Y, our I sub 2 is equal to 15 ampere. What is our I sub 3? That is equal to 10 ampere. What is our I sub 4? Take a look again. Our I sub 4 is I1. Okay? What is our I1? That is 10 minus I3. 10 minus I3 minus 10. 10 minus 10. Of course, 0. Sabay galiway. Okay. We have here I sub y. Is that correct? Our I4 is just 0. Okay, anyway, that's the answer. I sub 2. What is our I sub 2, guys? So we have 15, I sub 3 minus I sub 3. 10. Okay. That is 5 ampere. You see? Kita nyo, 15 minus 10 na lang, kinakalculator ko pa. Okay? So that we are very sure. Okay? It's very important in mathematics because if you have a mistake, typo error, or your positive becomes negative, everything will be wrong. Okay? That will be our answer. Okay? So, this will be for number 10, 11, 12, 13, and 14, guys. So, please take a look in here. What about for number 10? Okay, for number 10, I sub 1 is 10 amperes. Okay, that is letter B. Okay, for number 11, our answer on the board is 15 amperes. So that is, there you are, 15 amperes. What about now for number 12, which is I3, that is 10 amperes? We have letter A. Okay, what about now for number 13? It's just 0, meaning there's no current flowing. That is 0. And then, for number 14, the last item, we have here 5 ampere. There you are. Okay. There you have it. That is the Maxwell's Mesh Part 2 regarding the SuperMesh. Okay. Are there any question from our audience, from our Zoom class? Okay. So, pakita natin sila. Tingnan natin. Baka may mga tanong sila. That's the end, no? So, we finish early. Okay. So that you have your time to absorb what I discussed to you. It's time for you to solve some problems. If you have some review materials or books there, I want you to go back to textbook when you were in college. It's very important. It's very important. If you are already a graduate, no, what you have learned in your college days, just in case you are already a graduate, huh? So it's very important that you know the basics, the fundamentals, the concepts. That's the most important thing. Okay? From our non-Filipino audience, no, from time to time, I'm saying that this is for licensure examination. Don't bother with it, no. It's just so happened that many of the problems being solved are um, licensure exam, okay, or applicable to the licensure exam here in the Philippines. But just consider the principle. That's the most important thing. Okay, wherever you are in the world, no, wherever you are, the principle, the concepts, the basics, the fundamentals are the most important thing. The questions are there, but if you know the concept, any question you may answer that easily if you know the concept. Okay? Oh, baka may tanong kayo mga kawerpa. Leo, Joey, Sir Joey, Rodney, Santos. Ano? May tanong pa kayo o wala? Sige, kung wala, sige nga, mag-comment na lang kayo dyan. Sige, Sir Leo, kung wala, can I hear some comment with you? Sige, let us spotlight in English, ha? Okay, this is spotlight. We are still on YouTube live stream. Yes, Leo.
Hello, sir. Thank you for this teaching, sir. And it's look like...
Please speak louder, Leo. Pakilakas.
Thank you for your effort to teach us, sir, for free. And your method is easy to understand. But for us, we need to review it to know more techniques, to dissect all the techniques that you have teach to us. But it's look like easy to understand.
Okay. Okay, thank you, Leo. Salamat sa iyo. You have no question, Leo? You have no question? Ayan.
No more, sir. No more.
No more question. Thank you for the your positive comment. Okay, what about for Rodney? Rodney, any comment or question if you have, or suggestion, violent reaction? Okay? Are there any question, concerns?
No
Speak in
po, sir.
English.
No po, sir. Very clear po, sir. Then, look like very hard the problem, but it's too easy to to adapt the
Okay,
solution.
you are already in a graduating year in electrical engineering. Do you hear me,
Yes po.
Leo? Rodney, you hear me?
Yes po, sir.
Did you remember your topic, this topic, when you were, what year? Third year? Is that correct? This is a third
Yes
year
po, sir.
subject.
Yes, yes.
The electric circuits 1 or direct current circuits.
Yes, sir. I've
Okay.
already
Uh,
encountered this topic.
you already encountered this. How would you
Uh,
compare my way of teaching compared to the way your professor teach you this topic?
for me, sir, it's very easy to understand this. How about how you will explain the problem po, sir?
Sige nga,
Step by
Tagalogin
step.
mo nga. Tingnan natin. Sige nga, Tagalogin mo nga.
Sir, maganda po yung po, sir, yung pagkaka-explain niyo po, sir, sa topic na po to, sir. Kumpara sa nung nag-college po ako, sir, nung third year college po namin na-encountered namin to.
Okay. Sige. So, salamat sa iyo. Thank you. Thank you. Okay, what
Salamat din
about
po, sir.
Sir Joey? Yes, Sir Joey. Oh, nawala na si Sir Joey. Ayun. Sige, spotlight natin si Sir Joey. Sir Joey, so any reaction? Violent reaction?
Actually, sir,
What can you say for our lesson for today?
I learned much for this lesson for today, sir, about the SuperMesh analysis, and I thank you because your uh, your is very clear, sir. Very clear for us and easy to understand.
Okay, sir. So,
The way you teach to us, sir.
okay, thank you very much, sir. So, that will be it for today. Thank you very much to everyone. Okay, so you may leave now, everyone. So, everybody in the live stream, thank you very much. God bless you all. Salamat po.